Okay, so I think we can start the session. So last class, yesterday, like we have been discussing about some of my experiences, like working in drones. So basically, I had an opportunity to work with a university called Carnegie Mellon University as a um, research associate for like 6 months. So in that university there is a lab called Air Lab. So I worked in Air Lab basically. So the Air Lab is actually focusing on drones. Okay, so I got an opportunity to work on drones. But in reality, drones are not my favorite domain. My favorite domain is mainly into wheeled robots and legged robots. Okay, but like even I work with drones, all the software and everything was doing with ROS, so it was not a issue for me. So this was actually like we have discussed in the last class some of my experiences, and we have discussed up to like how to create a drone from scratch. Okay, so this session I am planning to start with that, how to create a drone from scratch in an easier way, and how to program using ROS. Okay, so we will be discussing like the existing platforms, both hardware and software, in order to create an autonomous drone, or like a complete, I mean, stabilized, fully controllable drone. Okay, so that is what we are going to discuss, and we will also see how to simulate a drone. Okay, I'm not showing any demos, but I will show you how to set up the simulation on Gazebo. Okay, so let's start with today's
Sir, can
class.
you ask some question, please?
Yeah, yeah, yeah. Kasim.
Can you show me some swarm like drones in Gazebo as well today? Swarm.
Uh, no, no. Maybe during that discussion, maybe we can. I mean, you can ask me. Okay, so mostly like I will be showing the setup instructions. Okay, but I can show you how to create a swarm. Okay, I can guide you how to. Okay. S
Sir, I will give you a little brief about me that I am a postdoc researcher
okay.
in Korea,
Okay. Okay.
and my mainly research also in drones and ground vehicle both.
Okay.
So I have many drones and I have many Turtlebot 4. I think you know about Turtlebot
Yeah.
4.
Yeah. Yeah.
Not So we have many latest robots in our lab.
Great.
So we
Great.
want to communicate with that. And my ROS is not good. That's why I joined you.
Okay, okay, okay. Got it, got it. Yeah. So let's see. Let's see. Maybe we can discuss more into it, like during the session. Maybe we can discuss.
Sir, one more thing I want to share that I need two ROS student for PhD. I will give very good salary
Okay,
there.
okay. You have an opportunity, right? Okay. So
Yeah,
can
two,
can
for
you
two
just
PhDs.
can you just share the requirements in the Discord? Like, so if anyone is interested, maybe they can they can check it.
Sure, sure.
Okay, okay, okay.
Yeah,
Thanks,
thank you.
Kasim. Yeah. So today we are going to see how to create a drone from scratch, and how to program it, and how to interface using ROS. Okay. So just want to share the droid, um, not droid, drone code foundation. Just a second, let me take it. Um, yeah. So drone code foundation, you can access this website. I can share it. So this is actually an open source venture, um, which is actually setting some open source standards, okay, for the drone industry. Okay, so if you are working with drones and working with open source, you might work with some of this framework, okay, some of the stack actually. So I can start one by one. First, I
Sir,
can, yeah.
excuse me, I cannot able to see the video, I think.
Okay. Just a second. Let me try to share it. Can you able to see the screen now?
No, I can maybe wait a minute. Yes, no, I can see. Thank
Okay,
you.
okay. So I think there was some issues with the sharing of screen. Okay, so um, maybe I can start with the Drone Code Foundation, which is a very important organization for drone related I mean stack, software stack. So we will be seeing some of the framework that is providing by Drone Code Foundation. While building the drone, we can see how these Drone Code Foundation will be useful to us. Okay. So let me start with building a drone. Okay, some projects. I'm taking some random projects, and it is actually showing from, yeah, it is actually included in the Drone Code Foundation website itself. So just want to share some random projects. Okay, a drone that is building from scratch. So if you check, this is a quadcopter, and you can see the frame is actually built using carbon fiber, and there is a GPS, battery, and there are some boards inside it. And here you can see they have connected the propellers, then the batteries, and they are talking about some flight controllers. Okay, and yesterday we have seen the ESC, then the motors, propellers, all these things are there, like if you are planning to build a robot from scratch or drone from scratch. So these are some of the list of materials that is available. So you can just buy these and assemble a new drone from scratch. But the main focus is not into the motors or ESC or something. We are mainly focused on to the flight controller. Okay. So let me just check. So by the way, maybe I can just repeat what I mentioned. Like we are seeing a drone project, how to build a drone from scratch. And you can see the screen, right? You can see the list of components. It's a quadcopter. So there are 4 motors, and these are some components, like it is having a GPS. GPS is what we are seeing here from 3DR. And there are ESC, then there is a flight controller. We will be talking about it. And you can able to see the communication. This is actually for communication between drones and the base station. Base station will be our laptop or the mobile phone or anything. Okay, so we can use this 950 megahertz transceiver for communicating. This is one way of communication. You can use Bluetooth, no Bluetooth, like Wi-Fi, or you can use any kind of communication based on your application. Okay, so this is just a project, and you can see the circuit of a drone here. That is what the important part. Okay, you can see here um, there are motors. Okay, currently only one motor is connected, and in order to drive the motor of the drone, yesterday we have discussed, we need an ESC electronic speed controller. Okay, it's a circuit like the motor controller, like the edge spreads. So the ESC is regulate the speed of the motors. Okay, there are 4 motors. So obviously you may have 4 ESC, or like a single ESC that can drive all the 4 motors. Okay, and for adjusting the speed of these motors, obviously it requires a power supply, right? So the motor power supply is actually going here from the battery to this power supply board. From the power supply, it is actually powering the ESC, and you can see here there is a central box here. Okay, the box is called Pixhawk Mini. Okay, Pixhawk or Pixhawk Mini. Pixhawk Mini is the mini version. This is actually the heart of the drone. Okay, we are going to discuss about more into this module. Okay, because like for any robot, if you check the components, the main components are like sensors, actuators, and the computer, right? So for a drone, if you are building a drone, the brain is one of the brain. Okay, one of the brain is going to be the Pixhawk or the flight controller. So what is the purpose of the flight controller? The flight controllers control everything. Okay, flight controllers control everything. So one of the flight controller is the Pixhawk. Okay, Pixhawk is actually an open source hardware project. We will be talking about Pixhawk after this. So you can see the Pixhawk is connected to a PWM board. Okay, and the PWM board is connecting to the ESC. So what may be the purpose of the PWM board? The PWM board can send the PWM signal to the ESC to adjust the speed. So who is actually sending the commands? The Pixhawk or the flight controller is sending the commands to the PWM board. The PWM generate the sufficient PWM. Okay, so the Pixhawk may be sending some control command like generate some PWM value. So PWM board will be generating it, and that will be going to the ESC, and ESC will be controlling the motor speed. Okay, so that is the actuator in the robot. Okay, in the drone robot, these PWM, ESC, and the motor is actually the actuator part. So what are the sensors? The sensors, you can see there is a GPS. Okay, there is a GPS, and that is a main sensor. And we can also see the telemetry. Telemetry mainly for like controlling the drone. Okay, so you can control the drone, like you can either remotely control the drone using a remote controller protocol, and also in order to get the sensor data or the information, we need a telemetry channel. Okay, telemetry. So this communication module is entirely for getting the data from the drone. Okay, telemetry information. And this receiver, I think it is for like controlling the drone. If you want to control the drone manually using joystick, you can use a joystick, and when we use the joystick, this will be receiving and moving the drone. Okay, and the telemetry is connected to a computer or like Android tablet. Okay, Android tablet, there is an application, so you can visualize the position of the drone. Okay, and you can also command the drones to go to one position to another using this app. Okay, so I think you got an idea how a drone circuit will looks like, right?
Sir,
Yes, but
sir,
Kalpesh.
kindly repeat about the telemetry part.
Yeah. So telemetry means so if the drone flies, it can actually send some information like GPS coordinate, right? Then if there is an IMU data, it can send. So all this information like sensor data, basically. Okay, it can be it can be sent from drone to the base station and vice versa. Okay, you can also send some data too. So maybe we can see the meaning of the telemetry. It's mainly using like the satellite the satellite communication. We are mainly using this. So basically like the measurements, okay, collection of measurements from a remote device. So here the remote device is the drone. Okay, so this is a simple circuit. Okay, this is a simple circuit that you can see, and we are focusing on the PixHawk. Okay, we will be seeing that. So let's just go through the assembling process. The flight controller or the brain of the drone, PixHawk Mini, is here, and we can see the assembly of the drone. We are not mainly focusing into it, but in order to get an idea, I'm just scrolling down. You can see the ESC for each motors, and everything is stacked in the center. And yeah, and this is the PWM board. Okay, so the PixHawk output is actually putting into the PWM board, and the PWM board connects to the ESC. Okay, it's connecting to the ESC, and this is the telemetry, 4-channel telemetry. There is a GPS, and you can see here the visualization in the app. So just want to show you a build. Okay, and I can also show you some other projects. So in order to get some understanding, you can see here on the left side, you can see different projects, drone projects. So you will get an idea how to build a drone, what are the main components. So the main objective is to like find what are the main components that we have to use to build a drone. Okay, so if you just scroll down, you can find important components like GPS. Then if you want to connect some depth sensors, you can see. So most of the project, they are not mention all the sensors and circuit. Only some projects is having all the instruction. Okay, yeah, I think this is having most of the instruction. This is another project. You can see here the flight controller or the brain of the drone. One of the commonly used board in the drone is PixHawk. Okay, PixHawk. This is again PixHawk Mini. Because of the size, I think PixHawk Mini is very compact. You can put it, and from the PixHawk Mini we are taking the output to the PWM. Okay, and this is like a ready-made board that you can buy from online. That is the topic that we are going to discuss next. Okay, so the PixHawk is the flight controller, which is having all the things that is used in the drone. Like it is having the input output for the GPS, then the output for the motors. All the things are there. So just search for the PixHawk. That is the important topic. So if you want to know about PixHawk, just search for PixHawk. So you got a website, PixHawk. This is a official website, but in the website, I don't know, like you will get much idea, but maybe I can explain. Let me check which is the best links to follow. Okay, let me try. Let me take some images as well. Yeah, this will work. Okay, so I think you can able to see the screen, right? Yeah. So the PixHawk is an autopilot board that we can use in the drones. Okay, so what is the purpose? The purpose is this board is having a microcontroller. Okay, a microcontroller, and that microcontroller can be flashed can be flashed, and that microcontroller will be doing all the computation to fly the drone. Okay, so maybe I can show you the software architecture that is happening inside the PIXOC board. Okay, so I mentioned that the PIXOC, inside the PIXOC there is some microcontrollers. Maybe I can show you what is inside this PIXOC board. Maybe tear down. Yeah, let me show you what is inside. This will be good. Okay, so the PIXOC board is will look like this internally. Okay, so what's inside is basically an STM32F based microcontroller. Okay, and you know it's actually a very powerful microcontroller, I think running on 80 megahertz or something, ARM based microcontroller. And what we can do is this is like a ready-made board, okay, that is available, and you can see there are a lot of connection from this controller. So if you check the PIXOC board, on the top part of the PIXOC you can able to see a lot of ports. Okay, and also on the side you can find a lot of ports. Okay, let me take some good boards. Yeah, so here you can see there are ports, dedicated ports for USB, SPI, serial communication, GPS, CAN, I2C. Then there are some LED indicators, and you can take the flight commands, I mean controller commands to the motors on this side. So it's like a ready-made board, and like you can compare this board like Arduino board. Okay, Arduino board, what is happening in Arduino board, we can use the Arduino IDE to flash the Arduino board, right? So we don't need to worry about the internals, what is the microcontroller using, what is its registers. We don't need to worry about it. Likewise in PIXOC, there are some researchers, I think from Zurich University, ETS Zurich, I think they created this module. Okay, this is actually a standard, okay, hardware standard. And what you can do is you can flash these PIXOC using some firmware. Okay, some firmware. So what is the firmware that we are loading into the PIXOC? That is actually the flight controller. Okay, this microcontroller will be running that firmware, and that firmware is doing all the things like you can see here. Just a second. Yeah, this one. Okay, so this is one firmware that we are using inside the PIXOC called PX4. Okay, PX4. So the PX4 is an open source project. Okay, and what is inside the PX4 is that it is having flight control. Okay, flight control stack. Okay, and you can simply use this stack, you can compile it, and then you can load it into the PIXOC board. Okay, so what are the things inside this flight controller? There is autonomous flight, position controller, attitude controller, location. I mean, all these are very, very complicated. Okay, so if you are creating a flight controller from scratch, it will take a lot of time actually, because you have to implement all these things from scratch. Okay, yesterday I have mentioned that my friends actually tried to create the drone from scratch, and finally they couldn't able to fly the drone because they were trying to create the flight controller by their own. Like they have taken the inputs from IMU, all these things, but it is very, very difficult to create. I'm not saying it is impossible, but it will take a lot of time. That's why we people are going with these kind of boards, okay, like PIXOC, so that you can simply use this board on your drone, and you can simply connect the circuit, like as you can see in this in this project. You can see we are simply using the Pixoc board, okay, Pixoc Mini here, okay, and simply assembling it. We are not inventing anything. We are simply buying it and connecting it and then configuring this Pixoc. But otherwise, if you are creating a drone by your own, you are replacing the Pixoc with a microcontroller or a Raspberry Pi, okay, and the Raspberry Pi or the microcontroller is running entire flight stack, okay. I hope you are clear with the flight stack that I am talking about. The flight stack is responsible for all the balancing, all the things in the drone, okay. So the Pixoc can be flashed using the PX4 software, okay. One of the software stack is PX4. So what you can do is you can flash it and then you can test it, okay, test it in some simulations, okay, so that we will be talking about, and after testing in the simulation, we can test it in the actual hardware, okay. So there are many methods to do that. So let me start with the PX4. Then only I think we can talk about the use of ROS there. Just a second, let me take that diagram again. Okay, yes, let me take this diagram. So this is actually the software architecture that is.
Excuse me, I hope.
Yes, Kasim,
Sorry to interrupt you.
no problem.
Yeah, there are, according to my research, there are two platforms. One is PX4, second one is Arduino Pilot.
Yeah, so
So
Pilot is actually,
which one is
Pilot is actually like not actively maintaining now. I have also, search about Arduino Pilot as well. So that's why I mentioned in the syllabus the Arduino Pilot. But I think when I searched again, that is not maintaining now. They are not actively maintaining now. So that's why I'm planning to focus on the Pixoc. Pixoc is actively maintained by the Drone Code Foundation. Not Drone Code Foundation. It is actually having lot of Pixoc based boards are available. So I thought like ignore Arduino Pilot because I think when I searched about it, the support they are actually not good. So what is your experience, Kasim? Are you still using Arduino Pilot or?
Yes, sir, I am using Arduino Pilot and I think they are maintaining because I am with their developers.
Okay,
So
okay,
last week I
okay. Maybe
released it.
I actually searched. Maybe I can do it again. Yeah. So, but when I searched about, but I'm getting like Pixoc is better than Arduino Pilot or something. Do you have anything to say which is better, Pixoc or
Yes, sir. Arduino Pilot is a little bit easier than PX4, but both working is almost same.
okay.
But the PX4 is a little bit difficult to control, but Arduino Pilot is very easy.
Okay. So maybe I can maybe talk about little bit about Arduino Pilot as well. So the PX4 and Arduino Pilot are the two software stack that we can flash into the Pixoc. Okay, so if you have a Pixoc board, you can actually get Arduino Pilot or PX4 project, and you can flash into the Pixoc board. Okay, and so I was actually focused on PX4 because it is properly maintaining by Drone Code Foundation. So I thought like talking mainly about the PX4 thing. So don't confuse about this terminology. I can clarify again. PixHawk is a hardware board. Okay, even I had this confusion. PixHawk is a hardware board. That is actually the autopilot that we are using in the drone. Okay, so in the drone project, if you check the center part is the PixHawk. Okay, so in order to work with the PixHawk, we need some software. Okay, so PixHawk is having a microcontroller, an STM32 microcontroller. You need to flash it. Okay, so there are two, I think mainly two software stack available in order to flash the PixHawk. One is PX4 and one is ArduPilot. Okay, I think ArduPilot came first, I guess, and then the PX4. So both can be, I mean, based on the requirement, I think we can use I mean whatever we want. This is actually the architecture that I got from the Drone Code Foundation about the PX4 software architecture. So I'm actually showing this architecture because to show the communication. Okay, so if you load this firmware into the PixHawk board, what you will get is that in order to interact with the PixHawk board, there are some communication showing, like on the left side you can see external connectivity. Okay, external connectivity. So if you want to communicate with the PixHawk board, for example, in this drone project, you have the PixHawk, right? And if you want to control the PixHawk from a computer, okay, from a computer. Yesterday we have discussed about the DJI drones, right? We have talked about the DJI SDK, and from DJI we can able to control the flight controller using a PC. Okay, I talked about the project that I have done with the TX2, right? So similarly, if we want to control the PixHawk, okay, so when we compare with the DJI, DJI has a flight controller, and in this drone the flight controller is PixHawk. Okay, so if you want to control the PixHawk, you can able to do that using a protocol called Mavlink. Okay, so let me show you that. That is the important part of this. You can see here there is a external connectivity. There is a protocol called Mavlink. Okay, what is a protocol? A protocol means a set of standards. Okay, a set of standards that we are keeping, right? Like ROS is having TCP ROS protocol, I mean communication protocol. So the sending and receiving of data will be wrapped in some format. Okay, that is actually, we can call it as a protocol. So here the Mavlink is a protocol, and you can communicate with the flight controller, which is the PixHawk, using UART. Okay, serial communication, RS-232 or UART communication. So basically, let me just take a PowerPoint presentation so that will be clear to you. So let me take it. Okay, so we have a drone, and the drone is having the flight controller, here it is PixHawk, and this flight controller is basically controls the drone, and it's also like receiving the signals like sensors from the drone, like IMU and GPS. And you can actually communicate to this flight controller if you want to. Okay, otherwise what you can do is you can simply directly sending the commands to the flight controller using an RC receiver. Okay, so if you have a joystick, the RC joystick and this receiver can able to communicate, and you can able to control the drones manually. Okay, but in case if you want to create an autonomous drone application, you can still use this manual control. But if you want to take control of this flight controller, control means if you want to send the command velocity to the drone, okay, and take off, landing, all these things, you can add a computer. It can be Raspberry Pi or TX2. Okay, so from the flight controller we will get some data about the sensors, and to the flight controller we are sending or commanding some data. Okay, so if you are using PIXOC, there is a protocol that we are using called Mavlink. Okay, so I'm actually talking in a very abstract level. Okay, there are a lot of things to learn actually, but this is just for beginners. Okay, so we are actually coming to the ROS part of it. So in order to explain the ROS part and the gazebo, I need to explain this as well. Okay, for beginners. So Mavlink is the protocol. Okay, so how the communication between the Raspberry Pi and PIXOC is happening? We have the UART. Okay, UART communication. So there are multiple pins in the PIXOC controller, right? So you can take the main UART in and connect to the Raspberry Pi. Maybe you can use an UART to USB converter, or you can directly connect to the GPIO pin of Raspberry Pi. Okay, and inside Raspberry Pi we have the autonomous application running. Okay, so this is one way of doing, like creating an autonomous drone. Okay, and if you want to control the Raspberry Pi, you will have like some Wi-Fi communication or some kind of communication you need to establish with the Raspberry Pi. Okay, this is one way of communication. Similarly, you can transmit the data, this Mavlink protocol into the base station, but better will be like putting a computer in the drone. Okay, I think I have explained in the last class, like for my project in CMU, like I think I have shown you that, right? NVIDIA autonomous drone actor filming. Let me try to get, yeah. So this was a project I have shown you yesterday. So in order to do that, the drone is equipped with 2 TX2. Okay, so this TX2 is communicating to the DJI drone using the RS-232 or like the UART protocol. Okay, similarly for the PIXOC we are using UART using the Mavlink. Okay, so how Raspberry Pi can communicate to flight controller using Mavlink? Okay, there are some libraries and there is a ROS driver as well. It's called MavROS. Okay, it's very famous. Okay, if you already work with drones, you may already know. So just search for MavROS. So if you set up MavROS on the Raspberry Pi, you can able to communicate with the flight controller. I already shown you the DJI onboard SDK ROS package. So if you run that ROS package for the TX2, you can control the DJI drones. If you run the MavROS, you can control the PIXOC board. Okay, so this is the driver that we need to set up on the Raspberry Pi or any onboard computer, okay, to control the flight controller. Okay, so these are some commonly using ROS stack in order to control the PIXOC. Okay, and so you may be thinking like, yeah, so this is for the hardware, right? How to control the real drone. Okay, so what about simulation? Okay, so yesterday I mentioned like working with drone is not easy. Okay, even the testing, I had a very difficult time while working with drones because our project was like very hectic. The weather was not good. Also, it's not a, I mean, simple project. It's an autonomous application, so we need to test it aggressively. Okay, even if there is any bug, we have to fix it and run it again. Okay, so running in simulation will give you a better idea, better clarity, whether your drone application will work or not. Okay, so literally what we are testing is we are testing the autonomous application that you have written. Okay, so instead of flying the real drone, okay, you can actually use a simulator drone here. Okay, you can actually use a simulator drone. I'm not very expert in that, but I have seen people using it. Okay, so what I understood was if you have the flight controller, okay, if you have the flight controller, if the flight controller getting the data from a simulator, it can able to perform like in the actual scenario. Okay, so here what we are doing is we are actually including the real flight controller in the simulation. Okay, so we can your application can send commands to the real flight controller, and the real flight controller data will be showing in the simulation. Okay, so if there is any problem with the flight controller or any issues with the flight controller, you can able to find it. Okay, so I just want to show you some simulations that we can use it with the PIXOC. Okay, so let me take some links. In the same website that let me check. Okay, okay, so I have actually put some links here, some interesting one regarding the PIXOC, and so in the user guide, the PX4 user guide, they created a good documentation. Okay, and this was some diagram. Yeah, so the block diagram snapshot. Okay, this one, right? Yeah, let me take a it's actually very simple. Yeah, I will share it now. Okay, yeah, so this is again one more diagram, like using the PIXOC, not the PIXOC mini. You can see the circuit, like the GPS is connected here, then there is buzzer, there is telemetry, then there is ESC, like you can see here there is 4 in 1 ESC, like one ESC is controlling 4 motors, and the battery, then the switch, almost all the things that we have seen. and there is a tablet in the telemetry part, okay, for visualization and for the autonomous. So in the tablet you can actually put the location, okay. So if you want to move the drone to one location, one GPS location, if you want to like move some zigzag movement, you can command it in the tablet and that will be obeyed by the drone, okay. Okay, so what we were talking about the simulation, just a second, I actually taken, yeah, yes, so let me take, or I can check it like, okay. So just want to share this link to you. So like you can work with the Pixoc board, okay. There are different ways to work with a simulation. Okay, so this is one way. Like here they are using software in loop, okay. There is no Pixoc board involved. You can see here, I think, let me check. You can see here the drone is flying in the gazebo. I think it's using the gazebo plugin mostly. You can see the architecture here. So there is a plugin, and the plugin is communicating to the Mavlink protocol, which is going to the SITL. I can talk about it. Let me check. Yeah, so basically, like in order to simulate the drone, there are multiple ways. Like one is using the actual hardware, okay. So if you want to include your Pixoc board on the simulation, you can able to do it, okay. So that is actually hardware in the loop, okay. And also you can test it on the software as well. So I'm little bit confused in that. I have seen the hardware in loop, like the Pixoc board is connected to the simulator, okay. It is connected to the PC and the PC is running with the simulator, okay. So when you give the commands to the real Pixoc board, the drone in the simulator will move, okay, and the simulation will be giving back some data to the Pixoc flight controller as well, okay. So what is the advantage of like testing the Pixoc board with the simulator? Because you can save time. Like if you want to test your autonomous application, what you can do is you can use the simulator in the loop, so that you don't need to go out and test the drone, okay. You can simply sit in your computer and then test it using the flight controller, okay. So this is it seems like a car with the Pixoc board, okay. Car which is having the Pixoc board, it seems. Yeah, I think it is completely, they are not using the real hardware. Instead of that, we are getting the data from the gazebo itself, okay. So the gazebo is giving the Mavlink commands to the simulator on the right side. So you can see the position of the robot is updating. Okay. So I just want to show you some simulation or simulators that we can use it for hardware in the loop and software in the loop. Okay, so you can see here. First, let me share the link. So you can see here the software in the loop and the hardware in the loop. We can test the both mode. I think I have a correction in the software in the loop simulation. So in the software in the loop, where the flight stack run on computer, but in the hardware in the loop using simulation firmware or in the real flight controller. So hardware in the loop is having the real flight controller, but software in the loop is running on the computer itself. Okay, so that is the main difference that we need to note here. I have actually seen the hardware in the loop basically because the Pixhawk board was involved. Okay, but you can run the PX4 autopilot on your computer as well. Okay, on your computer as well, and you can simulate it. Okay, so these two things are different. Okay, one is we are running the flight controller firmware, which is PX4 here, in the real flight controller, that is the Pixhawk, and software in the loop simulation is actually running the PX4 firmware in the computer. We can able to run the PX4 software or PX4 firmware in the computer itself. There is a way to run the flight controller in the computer itself. Okay, so these two methods are there in order to simulate the drone. Okay, so you have to be careful in that. I also had some confusion because I'm not an expert in drone, but I have some idea, like some project I have done based on that understanding I'm talking. So these two methods you have to aware, and then you can see the available simulators. Okay, to test the drones. The Gazebo simulator is there, Flight Gear, JSB Sim, Mav Sim, Air Sim. So Air Sim, I think yesterday I have shown to you. This is the simulator that we have used for the drone project. Okay, so the advantage is already mentioned here. It's very realistic, but the Gazebo, if you talk about Gazebo, it's very easy to work with Gazebo because there are a lot of community support, but it is not realistic. Okay, the simulation environment is not very realistic, but we can able to get all the ROS technology. We can interface with ROS easily. So Gazebo is like first one in the choice. But even for AirSim, the problem is that it is actually realistic, but it is very difficult to set up. Like if you want to edit something, for example, if you want to edit the robot model, if you want to add a new sensor, then you have to rebuild the entire project. Okay, AirSim is actually a Unreal project. Unreal is a game engine, Unreal project. So you have to modify the project and rebuild it. Okay, it's not very easy. Okay, so this is the main simulator that we are using, and this link actually talks about like how to set up the Gazebo simulation, then air simulation. I didn't set any simulation for the demo, but I just want to show you some examples. Okay, some videos only. Okay, I think following this documentation will be the best choice to start learning. Yeah, so let me just take it. So if you want to start with the simulation, yeah,
Sir,
yeah,
excuse
yeah,
me.
Kasim.
Can I share one link where you can find the PX4 autopilot from start to ending? You can become means the professional in drones. Can I
Yeah,
share
yeah, yeah,
the
sure,
link?
sure.
I will share. Then you can see that everything is in ROS based.
Okay, okay, okay.
Where I have to share
On the
here?
RDLP
I
discussion.
don't know. RDLP discussion where it?
So I already shared the PX4 link.
Let's
This is actually,
check this
yeah, yeah,
one.
yeah.
I think you know.
This is for the Ardu pilot, right?
No, sir. PX
Okay,
both.
both it is supporting. So, it is
You can see it.
okay. It is having some okay documentation. Okay, 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 okay. Yeah, I think it will be useful.
Also video available. Video also available.
Yeah, I think it will be useful because it seems like it is setting up in yeah in 20.04. Yeah, it is taking some time to load. Yeah, yeah. It seems like it is having everything. Hmm. Good, good. Let me just start it. Just a second. Okay. So maybe we can also use this. It seems like nice one, but the repository is not properly maintained. But yeah, it's fine. It's fine. Content is there. Yeah, almost. A lot of tutorials are there. Okay. Thanks for sharing. Yes. So this is for the PX4 setup. If you want to work with the gazebo and the PX4, you can able to follow this. Okay, and I don't have any simulation for now. Let me check in the next class whether I can set up anything. Yes. Okay. So if you want to like work on the drone simulation, okay. So I think Kasim is having a question how to work with multiple drone using gazebo, like or single or swarm robots in gazebo. So mostly if you work with the gazebo simulator, even if it is a drone or a mobile robot or anything, the easiest way to add multiple robots is by changing the namespace. Okay, so like changing the namespace in the controller, you can easily add multiple robots. Okay, the problem is that when you add a new robot in the gazebo, what happening is that, for example, in case of mobile robot, we have a command velocity, right? Similar to that, drone is having command velocity. So if you have multiple drones, you should have a namespace like drone 1 command velocity, drone 2 command velocity. I think you remember like how we can work with the turtle sim, right? So while working with turtle sim, when you create a new turtle, it's actually creating turtle 1, turtle 2, turtle 3 namespace. Okay, so that is the best way to isolate the topics and services using the namespace. So Kasim, can you just mention the exact problem, like while working with the multiple drones, like did you try with the namespace stuff for working with multiple drones?
Yes, I did, but actually I want to do some management of swarm of drones, control, for example, the drones and the ground vehicles with both.
Okay, so
Like RMF,
open
well, I think
RMF.
about open.
Okay, okay. So
Yeah.
you are facing challenges not in creating the simulation, but in controlling the drones, right? Swarm of robots.
Yeah,
Okay,
exactly.
okay, Okay, that
Yes.
is not actually in our scope, but the thing is that like yeah, OpenRMF is a solution, but I think um, that is mainly available for ROS 2, right? OpenRMF. I'm not sure that is
So both available, ROS 1 and ROS 2 both.
okay. Okay, I think they are giving more support to ROS 2 nowadays. Yeah, let me check. Yeah, 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 yeah. So did you try this project or are you able to like you are trying now?
Sir, actually, I'm working on it.
Okay, 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 okay.
But I discussed with the OpenRMF team. They told me that no, we are not. This is only for the
Yeah,
ground
yeah, yeah.
vehicles, not with
Yeah,
roads.
yeah, yeah. So that's what I also thought because as per the demos, they are focusing on like wheeled robots and which is having a map and all. But for the
You can say that for 2D, not for
exactly,
3D.
exactly, exactly. Yeah. So that will be a problem. So there may be some other software stack for the SWAM control, or we have to write our own. I think writing our own SWAM algorithm
That one is
very tough.
very tough,
Yes,
sir.
yes, yes, yes. So I think somebody may work with it, but we need to find the appropriate repository to do it actually. A single drone I have seen, but multiple drone I don't have much expertise. I can able to like add the multiple drone in the gazebo, even to air sim and all, but to control these drone is a separate topic. It's actually the application side of it, right? So I will say those are in the research domain. Those are coming in the research domain. But setting the simulator, setting the drones, and like flying with it, those are like the system level. Okay, so in this class we are like more into the system level, how to set up the stack, how to do the simulation, all this stuff. But the application is actually a big area, like what are the things that we can do with a single drone or multiple drone. Okay, so that is a different domain. Maybe next class maybe I can talk about some application like mapping, navigation. Let me see, maybe in the next class I can include. Okay.
Sir, can
But
you next
yeah,
can you show everything with some simulation, with
uh,
simulations in
yeah, yeah,
gazebo
so
and YouTube?
currently I didn't set up any simulation. That's why I actually mentioned I am actually quite lazy to do that actually. So maybe next class I am planning to set up. There are some script available. I'm not sure you tried with the PX4 simulation. Did you try this simulation before, Kasim?
Yeah,
This one?
I did with
Ado
the
pilot only.
pilot
Okay,
PS4
okay.
both.
Maybe I
Yes.
can set up for the.
No, I did with PS4 as well.
Sorry.
I did PX4 and
Okay,
autopilot
okay,
both.
okay, 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 okay.
Yeah. Well, I developed a drone delivery project
Okay, okay.
on
Nice, nice,
PX4.
nice. Okay.
Yeah.
I think. Yeah, yeah.
but I can add a point. One is XT drone that is they built on a PX4. It's like a gazebo
Okay.
simulation, and there you could find multiple UAVs. You can control with the keyboards.
Yeah, yeah.
Yeah,
What is the
two
name? What is the
two
name?
drones.
Can XT
XT
drone.
drone.
Okay.
Yeah. So these are Chinese people. They made on gazebo.
Okay.
So it's a quite good actually.
Okay, okay, okay. But the main problem that Kasim facing is he's having the setup for the multi drone, but the application side, how to control this multiple drone, like how to control a swarm of robots. This seems like a good, I mean, good resource. Uh, yeah.
Sir, this very well because I did my PhD from China.
Okay. I think you know it very well,
Yeah.
right? Okay.
Yeah.
So this is again,
I
yeah.
I contacted with this company already, and they have a course on this.
Okay. But Kasim, there is some SWAM related application is also here. Can you able to see here?
Yeah,
Yeah.
I
So
can
I
see.
think this stack is having something. It's all in Chinese, but maybe something you will get. They are like,
But
Currently is
but
not.
somewhere
Uh,
in English version will be there. If you scroll down
yeah.
somewhere, English version will show.
Okay. Maybe
English
on the
version
top
will.
itself. Yeah.
So actually, I made two drones flying. One drone contains camera, and it is supposed to detect other drone.
Okay.
This was worked in the simulation, but in the simulation, drawback is ground truth is not coming out.
Okay. Yes. So this is having, yeah, this project seems good. They are like using the PX4, then ROS layer. Yeah, interesting. Yeah.
They have multiple papers,
Yeah,
publications
and
as
they're
well.
also having like mapping. Maybe we can demonstrate the mapping of this. This seems interesting. They
Sir, in the next class, can we formulate this XT
Yeah, maybe we
drone
can discuss
on?
it. I need to set it up. Maybe we can discuss. So like as per your requirement, like there is SWAM motion planning is also there, Kasim. So better
Yes.
to check this. It seems interesting. Yeah. I think they're working on the SWAM. See the formation. They're playing something with it.
Sir, actually, my problem is controlling drone and ground vehicle both.
Okay. But
And
yeah, maybe um, I'm not sure you have heard about this challenge, MBZIRC challenge. So this challenge, the first challenge was that. Let me take it. 2000, yeah, autonomous landing. Yeah, I just want to show you this. I actually work with this challenge in the first challenge. The the objective is that the drone have to land in a moving a ground vehicle. Okay, so like the ground vehicles is having a QR code, and the drone has to detect that, and then it has to land on that vehicle. So this challenge was about it. So are you working with similar kind of project, Kasim? Like this is a communication between the drone and um, the vehicle.
yes, sir,
Okay,
look like
okay,
same almost.
okay.
Yes.
Yeah.
But with the swarm, with the
Okay. I
multi-agent
think you are working
based.
in a very, I mean, very complex domain, it seems. Yeah. So this is a simple application, like landing the drones on a moving vehicle, but itself, like that challenge itself is difficult. Yeah. Yes. Okay. Okay.
Okay.
So I just want to conclude. So today we have discussed some uh, concepts like for beginners, like if you want to build a new drone, we have set of flight controllers available. One of the flight controllers is Pixhawk, and inside the Pixhawk you can flash different firmware. One is PX4, one is Pilot. You can flash it, and then you can connect all the motors and everything, and you can fly the drone. Okay, very easily. It's like a ready-made kind of module. And if you want to simulate the drone, you can do it. with the help of the hardware or this or running the PX4 or Ado Pilot on the PC. Okay, and that is for the simulation. The simulation setups are mentioned in the in the in this user guide. Let me try to set up that. And next class, yeah,
Sir,
yeah,
sorry,
yeah, you have
interrupt you.
shared.
There is a drone dojo. I think they providing only for $1. They providing a course for 1 month, only
Oh,
in one
okay,
dollar.
okay, okay, great, great,
Yeah, only I think for 1 month access. I
great.
think. Yeah.
So they're providing like, yeah, okay, okay, okay,
Complete yeah, drone
okay,
development.
okay, okay, nice, nice.
Very good course. I take this course
Okay,
already.
okay, okay, okay.
Can you share the link,
Yeah, it's
please, so
already
that
shared.
we
It's
can
already
utilize
shared.
the.
Already yes.
It's already shared
Okay.
in the Discord. Yeah, this seems interesting.
Can you check the course? Very good.
Okay, okay. Yeah, here's this Raspberry Pi. I think I mean many people are working on drone in our group, right? Like Kasim is there, yeah, and Bharat also. Yeah, you both are working on the drone, right? Yeah, great, great. Okay, okay. So so next class, let me try to set up some simulation for the drone, and after that we can also check the X3 drone. I think I have heard this somewhere. Let me see how to set up this. So if we can explore the mapping and all, that will be interesting. I have planned some different algorithm for the mapping, but this seems more interesting because they have a reconstruction 2D slam. Interesting. Yes. So let me try to set it up, and then we can discuss in the next class. And after that we can conclude the drone chapter, and we have to jump into the last chapter, which is the state machines, so that we will be discussing after that. Okay, okay, so we can conclude today's session. Hope you got some idea. I mean, this session is primarily focused on beginners. I know a lot of people already know this, so maybe by this chapter some of you got an understanding like what are the things that we can do with ROS and a drone. Okay, so I talked about not only Pixog, I talked about the DJI drones that I worked personally. I have a good understanding in DJI onboard SDK and AirSim simulator. That is a main area that I worked. And I have also seen the Pixog working, Pixog project. So I only have that much of expertise in this domain. Okay, so if you have more links or tutorials, you can share and we can discuss that as well. Okay, so now it's a time for questions and yeah, discussion. So let me know if you want to discuss anything or if you want to ask any questions. Kasim, do you have any question?
Well, sir, was just a timing issue. Actually, here is midnight,
Yeah,
1
yeah,
a.m.
yeah, yeah. I got
And
it. Yeah, so
Even me, actually, I am outside today, Saturday. It's here
uh, th
3:30.
uh,
So I,
3:30 p.m., right?
so
Yeah, yeah.
yes, yes. So it is. I'm just following up in my mobile. You can see outside some noise at
Okay, okay.
backside. So I'm not on and off.
Got it,
I'm
got
doing
it.
it. So is
Yeah,
it
so
recorded, right?
today there was a change in timing. So like Kasim is interested in the drone side. He's doing the postdoc in Korea, mainly in the drone. But the chapter is not about like I mean more not into the drone. It's like an abstract overview of the drone and how to work with the ROS and drones interface and all. So yeah, anyway, like at least people who are having interest in the drone could able to join this class and we could discuss something. Hope that is useful to you guys. And next class I will try to set up some simulation. I'm quite busy, but let me try to set up some simulation for you and we can discuss based on that. Yeah, so I think that's it. Is there any other question?
Can you check another link I shared? That is also very good if
Yeah,
anybody
let me
interested.
take that link. Open source autonomous drone project. Oh, great. So okay, so this is also involving mapping. Okay, interesting. Okay, and it's also talking about the multi-drone formation. Okay, yeah. I think there are a lot of demos. Interesting. Thanks for sharing, Kasim. Yeah.
Sir, it's better if next class is also arranged a little bit earlier.
Okay, I will try my best. Yeah. Okay. So if there is no more questions, I think we can conclude today's session. And next session, let me plan. I will announce. And for if we can plan early, maybe if I'm planning early, I can announce it early so that everyone can
Sir, I have one question. Have you worked on nonlinear MPC implementation on some drones
no. I mean,
like that?
I already mentioned, right? So the thing is that my main expertise is in the wheeled robots, and
Also in wheel robot is also is okay if you implement it a nonlinear model predictive controls.
no, actually, I need to look onto it. So let me maybe
Okay.
you can just message me. So if I have any idea, then we can discuss. Okay.
Sure, thank you.
Because the drones, like I don't have any interest in this domain because I don't know, like from the beginning itself I'm not a fan of drone, so I didn't try to like learn stuff regarding drone. My main area, like these self-driving cars, then wheeled robots, all this stuff. But I have seen a lot of applications like the drone company that I forgot the name, Skydio drone. It's very good. But I'm not a drone fan basically. But we can discuss. Anyway, it's all ROS related. That's why I included this chapter because even I don't have interest in this domain. Maybe someone will be. I mean, someone will have interest. So yeah, I think it's good to add this chapter in this course so that at least you will get an idea. Okay guys, I think we can conclude today's session. So next class I can announce, and let me see, like I can come up with some simulation and discuss, and then conclude the drone chapter and start with the state machines. Okay, thanks everyone. Thanks Kasim,
Thank you,
Bharat,
sir.
who contributed.
Thank you. Nice.
Thanks everyone. Bye.